Alrighty, for today's lesson, you're definitely going to want a calculator because we're going to be doing some calculations that require us to simplify in our calculators. So make sure you have one today, and also make sure you're using one on your practice. So what we're going to be doing today is we're going to be working with slope. Okay, slope is like how steep a line is, okay? It also refers to if a line is positive or if a line is negative, okay? So for example, if I just sketch a little line up here, if any of our lines ever look like this would be a positive slope line, okay? So it's going up and to the right. If my line looks like this, that would be considered a negative slope. Today we're not going to actually look at lines, but I just think this is something important to kind of note so we have an idea of what we're working with today. So slope is looking at the rate of change in the y-coordinates. They refer to this as the rise for the corresponding change in the x-coordinates, which is the run. Okay, so anytime we hear slope, a lot of times people will refer to this as rise over run. Okay, now with this, rise is our y-coordinates and run is our x-coordinates, okay, or our y numbers and our x numbers, okay? Just to kind of even take another step back, when we're referring to ordered pairs, our x numbers are first and our y numbers are second, okay? So we're going to be doing a little labeling today, and then we're going to be doing some calculations, like I said, on our calculators. So make sure you have one. So it says down here is kind of where we need to be as far as our main idea for today goes. And that's going to be right here with our little slope formula, okay? So slope is indicated with the letter M. So anytime you see the letter M, that's referring to our slope value, okay? We'll see that a lot in this unit and our next unit. And we're going to be looking at 2 points, okay? So the slope between 2 points. How we label our points is like so, okay? The 1 and the 2 doesn't really mean anything. All it's saying is this is referring to point number 1 in our problem. That's the little ones there. And the little 2's here is talking about point number 2. Okay, so point number 1 and point number 2, those are going to be numbers that we'll end up labeling in our problem. And then we're going to be doing the slope formula, which is right below here, for each problem. Okay, so again, we're trying to see what's the rise compared to the run when given 2 points. On the next slide, there's not really anything we need to add. It just says the slope of a line can show how a quantity changes over time. When finding the slope of a line that represents a real-world situation, it's referred to as rate of change. So slope and rate of change, those kind of go hand in hand. We already worked on rate of change when we were looking at those tables and graphs. Now we're going to be kind of connecting that to slope with 2 given points. Alrighty, so we're going to be doing quite a few examples here. I just want to make sure you have plenty to go off of. The very first thing, I'm going to kind of write up a little what I would do as far as going through your tasks. The very first thing that I would do is I would label your x1, y1, and x2, y2, okay? That's the very first thing that you need to do when you start a problem, okay? Now, how you're going to do this is you're just going to use the first point. I'm going to put a little x1 here and a little y1 here. So that means my x1 number is -3, my y1 number is 4, and then here, same pattern, but we're going to change the 1's to 2's, so x2, y2. That piece is super important because if you don't do that, then your slope formula is not going to be correct. That's the second thing that we're going to do is we're going to use our slope formula in order to calculate the slope now, okay? I'm going to rewrite the slope formula every single time we do this, just so you can see it over and over again and kind of get that process down, okay? So first thing first was here, labeling those points. Second thing we're gonna do is we're gonna do our slope formula. So M represents slope, equal sign, big fraction bar. And again, I'm just grabbing this from the slide above. So it's y2, it's always a minus sign, and then y1. So our y's are on top. Then it's x2, always a minus sign, and then x1 on the bottom. So what we're going to be doing is we're going to be taking out these letters and replacing them with the numbers that correspond in our given xy coordinates in our problem. Okay, so we need to use what we did in step 1 to now fill in these boxes. Okay, so I usually write equal sign, fraction bar. Okay, so the next thing that comes on top is y2. If I look at my coordinates up here, y2 is 7, so I'm going to go ahead and write a 7 here. Again, I'm just getting that from what y2 is labeled. There's always a minus sign in between these two numbers, so I'll keep that in the pink. And then the next thing that comes is y1. If I look up above at what I've labeled, y1 is going to be the number 4. Now I'll jump to the bottom. Now I need to grab my x2 number, which is the number 1, minus sign in the middle. x1 is going to be negative 3. You do need that double negative there, otherwise it's not going to be correct. Now we're going to do kind of what we did a couple times ago, and we're going to calculate what's on top and what's on bottom. Okay, so 7 minus 4 is 3. 1 minus negative 3, if I put that in my calculator, it gets me 4. At this step, you need to plug this into your calculator and see if you can simplify. Okay, I'm going to put a question mark here because sometimes you can and sometimes you can't. Okay, we want to keep it as a fraction. So if I type 3/4 into my calculator, it ends up spitting out the number 3/4. So this is my final answer. And that's all we're doing today, okay? So I'm going to go ahead and scroll on over to the next slide here, okay? First things first, we need to label x1, y1, x2, y2. So x1, y1, x2, y2. I'm going to go ahead and rewrite our slope formula. M equals y2 minus y1 all over x2 minus x1. Again, we're going to be taking out the x and y's on the top and bottom and filling them in with the numbers that we see. Okay, so in our labeled piece up top, bring over your equal sign and your fraction bar. y2's first number is 10, so I'm going to go ahead and replace that spot with a 10. Minus sign in the middle. y1 is 8, so I'm going to write an 8 next to here. On the bottom is x2, that's a 7. Minus sign. x1 is negative 1, so negative 1 will go here. Again, please make sure you're using your calculator because that's going to make sure we don't get anything incorrect. 10 minus 8 is 2. 7 minus negative 1 is 8. Again, at this spot here, you need to check to see if this simplifies in your calculator. What that means is I'm going to type 2 over 8 in my calculator and see what it spits out as a fraction, okay? If I put that in my calculator as a fraction, it will actually simplify to 1/4. So that is a value that I want to have simplified, okay? All right, there are a couple more examples. I'm going to look at just two special ones. So I'm going to actually go ahead and skip slide 37. I'm going to go to slide 38 and 39, okay? Because these are going to give us special types that I want to make sure I look at. So again, go ahead and label x1, y1, x2, y2. We're going to start with m equals, and I'm going to write out our whole thing here. So y2 minus y1, x2 minus x1. We're going to take out our x and y values. I like to do this just so we can see what we're replacing here, okay? So we'll bring over our equal sign in our fraction bar. Y2, if I look up what I've labeled, is -5. So -5 will go first, minus sign in between. Y1 is also a -5, so -5 minus -5 is going to be on top. On the bottom is x2, which is a 4, minus sign in the middle. x1 is -2. Again, we're going to use our calculators. When I do that, -5 minus -5, that gets me 0. And 4 minus -2 is going to give me 6 in my calculator. At this point here, we're going to simplify, okay? And we get something unique here. What we get is the number 0. So this is when we have a horizontal line. A horizontal line is something that goes left to right, okay? So left to right lines, our slope is 0. Now if we jump to slide 39, this one's going to be a little bit different, okay? Again, we'll go ahead and label x1, y1, x2, y2, m equals, fraction bar, y2 minus y1, x2 minus x1. I'm just going to kind of jump next to the next piece here. y2 is -2, minus sign in the middle. y1 is 4. x2 is a -3, minus sign in the middle. And x1 is also a -3. If we do our calculations, I've got -6 on top, and then I get 0 on the bottom this time. When I type this into my calculator, I end up getting the word error. If I get the word error, it actually has a special word that goes with it. That special word is undefined. So if you get error in your calculator, you have to write the word undefined. Undefined slopes are for vertical lines, which are lines that are straight up and down.